Okay, so this one is much of the same. Let's go through it. And there's a little problem spot that a lot of students have. It's because they get tricked. And so I'm going to untrick the trick. Use linear approximation, i.e. the tangent line, to approximate the cube root of 1.12 as follows. Okay, let's just first of all remember that we can use linear approximations to approximate function values near that meeting point. Wherever your tangent line meets your original function, we can approximate function values near that point by just taking the line's values, whatever the line's values were, just take those. So as follows, let f at x equal cube root of x and find the equation of the tangent line of f at x equals 1 in the form y equals mx plus b. That is the L of x equals mx plus b. That's the same thing, just so that you know. Okay, we're doing the same old song and dance, so we need a slope, and then we'll need a point from the line to get a full equation of our desired tangent line. To get the slope, we again need to take a derivative, which in this case is f prime at x equals this. This is just your power rule. Remember that cube root of x is x to the 1/3, so the 1/3 comes down. 1/3 minus 1 is negative 2/3. Now, which slope do we want? This is the equation of the slope. This represents the slopes at any x value. Well, we only care about x equals 1. Why x equals 1? Because well, they tell us here, but also that is pretty close to 1.12. So getting that one will do a reasonable job. And I made a graph. So if we look here, let's make this guy a little bit bigger. Not this one, but this one here. Okay, so this is the graph. Blue happens to be cube root of x. Okay, you can see 1 cubed is 1, and then maybe out here 8 cubed is 2. See that, and blah, 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 blah. 27 should be 3. Now, if I turn this on, aha, so this has automatically generated my linearization. And so you can see everywhere it's, like wherever I put my A value, you can see the A value changing. That's where it's centered. That's where it's a perfect approximator of our blue function. And then if you zoom in, you'll see that points near our center point are approximated very, very nicely. Okay, so if we put this guy at 1, I don't know if I'll be able to do it there. Oh, I nailed it. Then we're going to be estimating 1.12, and that's like right here, which as you can see is very, very close. I have to zoom in a lot. It'll never actually be equal. Like these two lines are only ever equal at that one spot right there in this small neighborhood. Yeah, you can see it's starting to split off. See, there is an actual difference. Only at 1 is there no actual difference. Boom. So it doesn't matter how much I zoom in on that point, they will actually be the same. But then every other spot, I just need to zoom in enough, and there will be a difference. Anyways, okay. So yeah. So we know what it looks like now. We have a picture of what's going on. That's really, really helpful. To get our slope, we plug in x equals 1 into this guy. 1 to the negative 2/3 is just 1, so it's 1/3 times 1, which is 1/3. Nice. We also need a point that lies on our tangent line. Maybe just use the fact that f at 1 is equal to 1, right? So if we plug in 1 into this guy, we get cube root of 1, which is 1. That's a point that's going to be on our tangent line because we're centering it right there. And like I just said, that's the only point where the tangent line is actually equal to the function value. So that function value has to be on the tangent line. Okay, that'll give you your m and b value. So now you should be good at using a slope and a point on the line to compute the equation of the line. That's your m and b value. Slope, y-intercept. To solve the last part, keep in mind that we have created a function that estimates the cube root of a function for a given x value near 1. I know you accidentally put in cube root of 1.12, and you're a bit confused as to how the answer is wrong when the other parts were correct. Well, if you put in cube root of 1.12, I don't know what that number is. Do I have a calculator nearby? No, but that's what you would be estimating if you put that into the thing. The cube root of 1.12. We have a function which estimates cube roots already. So you would be estimating the cube root of 1.12 if that's what you put into your estimate. Our line, you just put things into the line and you put whatever you want and it gives you the estimate of that, the cube root of that input. So if you put this in here, it's going to give you the estimate of the cube root of 1.12, which is not what you're looking for. So yeah, don't do that. You need to think about which function you've approximated with your tangent line and how you use your tangent line approximation for different values on the original graph, to approximate different values in the original graph. So keep that in mind. Spend some time thinking about it. Take as long as you need to think about it. It's not easy. So good work so far. You're doing great. If you want me to personally help you pass your course, as usual, description down below. That'll do the trick. And we'll get you sorted. All right, thanks for watching. Until next time.